In the vast expanse of the universe, there are planets unlike any we've seen before. Planets with a treasure trove of diamonds. What mysteries do these sparkling worlds hold? What do they look like? And most importantly, just how much would it all cost? Let's find out. First of all, let's take a look at diamonds in general. We see them as rare and valuable gems. But did you know that they actually come from something as ordinary as carbon? That's right. This is the same element that's found in your pencil lead or coal. This is also the key ingredient in a diamond. But how does a plain old carbon atom turn into a dazzling diamond? Well, it all starts deep beneath the Earth's surface. At depths of around 100 miles, carbon is exposed to temperatures of over 2,000 degrees Fahrenheit and pressures of over 825 pounds per square inch. That's like putting the weight of 3 elephants on a postage stamp. Under these extreme conditions, the carbon atoms bond together in a unique way. They form the crystal lattice structure that gives diamonds their distinctive shape. This process can take millions or even billions of years as the carbon slowly makes its way closer to the Earth's surface through volcanic activity. And then, finally, the diamond is formed. After that, it may stay hidden in the Earth for thousands of years until it's brought to the surface through volcanic eruptions. From there, the rough diamond is cut and polished into the beautiful gems that we know and love. So, why are diamonds so valuable? Well, it's partly because of their rarity. Only a small fraction of the diamonds that are formed actually make it to the surface. But it's also because of their beauty and durability. Diamonds are the hardest substance known to humans, and they have a unique ability to refract light in a way that makes them sparkle and shine. Diamonds also have a wide range of practical applications. They're used in cutting tools, grinding wheels, and even in the tips of surgical instruments. And thanks to advances in technology, scientists are finding new ways to use diamonds in fields like electronics, energy storage, and medicine. All this goes to show that sometimes the most extraordinary things can come from the most ordinary of elements. Now that we know this, let's get back to our diamond planet. Can planets like this even exist? Actually, yes, they can. In fact, we come across diamonds in space much more often than on Earth. In space, extreme pressure and temperatures are very common. That's why the universe, and even our solar system, is actually incredibly wealthy. Your regular asteroid can cost millions of dollars. Helium, which we can find almost everywhere in space, has a huge energy potential. It's not surprising that humanity has been discussing the possibility of space mining for some time. Now, as I mentioned earlier, diamonds are formed deep within the Earth under conditions of extreme heat and pressure. Scientists believe that a similar process could occur on a planet that's rich in carbon. There are a few possible ways it could happen. For example, when 2 planets or asteroids that contain a lot of carbon collide with each other. The collision would create a shockwave that would push the carbon atoms together so tightly that they would form a diamond. The second way it could happen is if this region of space contains a lot of carbon. If the conditions are right, then the carbon atoms would come together and form a planet-sized diamond. It's like if you have a lot of Lego blocks and you put them together to create a big Lego structure. In other words, if 2 carbon-rich objects collide with each other, the carbon atoms can be squeezed together so tightly that they form a diamond. And now, surprise, surprise, these planets actually do exist. The planet we're talking about is called 55 Cancri e. It's one of the 5 planets in a small system in the constellation of Cancer. Its star is actually so bright that you can see it with the naked eye. It's located 40 light-years away from us, which may be trillions of miles, but on a space scale, it's pretty close. 55 Cancri e was first discovered in 2004. However, we didn't learn until 2012 that it was the first known diamond planet. All thanks to the research of scientists from Yale University. This planet is the super-Earth. This is a class of planets that are larger than our Earth. but too small to be considered giants. It's about twice as big as our Earth and about 8 times heavier. The planet rotates around its star really fast. It completes a full turn in just 18 hours. This means that 1 year on the planet is less than a day on Earth. It's also tidally locked to the star. In other words, one side of this planet is always turned towards the star and therefore is incredibly hot, while the other is in eternal darkness, just like with our moon. Also, 55 Cancri e is about 25 times closer to its star than Mercury is to our Sun. As a result, the temperatures there are just enormous. On the day side, they're just above 4,000 degrees Fahrenheit, and on the night side, which, by the way, is considered the cold one, over 2,500 degrees Fahrenheit. Doesn't really sound like a good place to chill out, does it? Well, it may not be good for us, but for diamonds, it's just perfect. After studying the planet, scientists concluded that it's a rocky world full of carbon. But this carbon isn't contained there in the form of gas. Instead, it's in the form of graphite. Yes, the same one found in your pencils. And, of course, diamonds. According to some estimates, diamonds can make up at least a third of 55 Cancri e. It can cost about $27 non-million. There are 30 zeros in this number. Can you imagine that? But the most interesting question is, what would such a planet look like? First of all, the thermal evolution and tectonic processes there are completely different compared to our Earth. In other words, the planet should be full of strange volcanoes and some bizarre volcanic activity. Weird mountains and stuff like that. In addition, the planet is probably covered with large clouds of dust, and the atmosphere on it is very dense. Oh, and the weather there is definitely crazy. The researchers are planning to learn about the composition of 55 Cancri e's atmosphere in the future, but right now it's already pretty clear that this planet can't be called habitable. Well, finding life there is theoretically possible, but it's very unlikely. Life on a diamond planet could potentially exist deep underground, for example. On Earth, we've already observed bacteria and microbes that can survive under incredibly extreme conditions. These guys are very resilient. They're capable of turning chemicals into energy and surviving, basically anywhere. So, on a diamond planet, life could potentially exist in this form. And who knows, extraterrestrial life may also take forms that are completely unknown to us. Wouldn't it be cool to discover some crystal creatures capable of surviving in the most extreme heat? That would be mind-blowing! And guess what? It's not just 55 Cancri e that's full of diamonds. Other potential diamond hotspots include Pluto's largest moon, Charon, and a Jupiter-style exoplanet rich in carbon found 1,200 light-years from Earth called WASP-12b. Scientists even think that diamonds rain on Saturn and Jupiter regularly. All this was discovered by the researchers from Arizona State University. They claim that diamond planets are not that rare at all. According to a 2020 scientific report, they form around certain types of stars that have high carbon-to-oxygen ratios. They went above and beyond to study these space gems. They subjected carbide silicon to insanely extreme pressures above 50 GPa and temperatures as high as 2,500 degrees Kelvin to see what would happen. And they discovered that under these wild conditions, carbide silicon transforms into diamond and silica. So if you're looking for some diamond bling, you might not have to go too far. You could go intergalactic and explore some of these diamond planets. These exoplanets are unlike anything in our solar system. And who knows what other awesome discoveries are out there waiting for us to find them.
So, a planet a few times bigger than Earth, where actual diamonds fall from the sky like rain, it already sounds pretty sci-fi. But trust me, that's not even the strangest part of the story. You see, scientists recently pointed the James Webb Space Telescope toward this world with a name that looks like my driver's license, and found out that it ignores many rules. Most planets, just like Earth, circle normal stars like our Sun. But the diamond planet, let's call it like that, circles a pulsar. This world circles something far scarier than a normal star. a pulsar, a type of neutron star. Pulsars are born when the massive star collapses and a supernova goes boom and wipes out all nearby planets. And even if those planets don't stop existing immediately, radiation literally strips material off of the companion star over time. Bit by bit, the pulsar eats it alive, like a cosmic cannibalism. But the new mysterious object isn't a star, it's a planet. And planets shouldn't survive anywhere near that kind of radiation or evolve into something chemically bizarre. But anyway, the pulsar that the diamond planet lives next to spins insanely fast and fires beams of radiation like a cosmic lighthouse made of gamma rays. Normally, stars blind telescopes when scientists try to study nearby planets, but pulsars don't shine much in the infrared light, the kind the James Webb Space Telescope detects. So, astronomers could see the planet glowing while its deadly parent, the pulsar, stayed almost invisible. They noticed that its mass, radius, and temperature are pretty normal for a so-called hot Jupiter. That's one of the rarest types of exoplanets. But then, things got weird. Well, weirder. First off, not so many pulsars we know of host exoplanets, and none of those planets scientists have spotted so far are gas giants. Second, the diamond planet shape is pretty weird. Because it orbits its pulsar at a distance of just around 1 million miles, it's really affected by its gravity, and that's why it has its unusual lemon-like shape. But the weirdest thing is the planet's atmosphere, which contains huge amounts of helium and carbon molecules. That carbon is floating freely instead of bonding with oxygen or nitrogen, like it usually does. Under temperatures between about 1200 and 3700 degrees Fahrenheit, carbon shouldn't survive in that form at all. On almost every other world astrophysicists know of, it quickly links with other elements. But our weird planet just ignores that rule completely, and none of the well-studied exoplanets act like this. It looks like the pressure deep inside this diamond world squeezes carbon so hard that it turns into diamonds, and they constantly fall toward the core like glittering hailstones the size of mountains. Scientists still don't fully understand what's happening with this diamond world. They tried comparing it to something called a black widow system. It usually has to do with two objects locked in orbit, a dense pulsar and a smaller companion star, similar to our Sun but much brighter. The diamond planet shows overwhelming amounts of carbon, far more than physics tells us is possible. It doesn't look like it formed like a normal planet from leftover dust and gas, and it doesn't seem like it formed from a star that got stripped down by a pulsar. So, as of now, it doesn't fit into any known formation scenarios. The pulsar may have erased a former companion star so completely that only an ultra-dense carbon core survived. Another idea is that extreme radiation reshaped an existing planet over millions or billions of years. Meanwhile, while scientists are solving this mystery, let's visit Uranus, where it also rains diamonds. Deep inside this ice giant, temperatures climb above 12,000 degrees Fahrenheit according to mathematical models, and pressure rises millions of times higher than Earth's atmosphere. Methane gets crushed until its molecules snap apart. The freed carbon atoms cling together, form crystal structures, and grow into diamonds. Those diamonds sink deeper, melt in hotter layers, rise again, and repeat the cycle endlessly. And not only that, the James Webb Telescope showed that Uranus's magnetic field tilts about 60 degrees off balance, which means the planet's invisible magnetic shield sits crooked compared to its rotation. On Earth, auroras stay near the poles, but Uranus spreads glowing auroras across huge regions of its atmosphere. Webb watched the planet spin for 15 hours, which is almost a full Uranian day, and captured massive energy flows moving through the upper atmosphere like glowing weather systems powered from deep inside the planet itself. All this means that ice giants distribute heat in ways we barely understand. Uranus almost rolls sideways as it orbits the Sun, and that strange orientation seems to twist how charged particles move through its atmosphere. Instead of neat polar light shows like ours, Uranus creates wandering auroras. Also pronounced wandering auroras that stretch across the planet like cosmic neon storms. Studying them can help researchers understand magnetic fields. It's a pretty big deal because they act like planetary force fields that protect atmospheres from space radiation. At the same time, another mysterious world has its own pretty weird weather system. I'm talking about Titan, Saturn's largest moon. Titan doesn't use water for rain or lakes. It uses methane, the same gas we burn for fuel on Earth. Scientists discovered that Titan's seas actually shape its local weather, just like the Great Lakes influence climates in North America. Liquid methane evaporates, rises, cools, and falls again as mist or rain. Warm air lifts upwards, while cool air rushes in behind it and forms convection cells, which are giant looping currents of moving air that drive storms. And not just regular storms we're used to. No! Titan has lake breezes, fog banks, and seasonal weather cycles that run on hydrocarbons instead of water. Titan's big brother, Saturn, doesn't just have weather. It throws atmospheric tantrums on a scale that makes Earth storms look like brief summer rain. When NASA's Cassini spacecraft orbited Saturn between 2004 and 2017, its instruments picked up lightning flashes so powerful they could shine even in broad daylight. On Earth, lightning already releases temperatures hotter than the surface of the Sun for a split second. On Saturn, some bolts carry 10,000 times more power than lightning here. Cassini even detected radio signals from these storms, which means researchers could literally listen to thunder rolling across another world. Some of these storms expand more than 190,000 miles wide, large enough to circle nearly the entire planet. Then there's Saturn's famous North Pole hexagon, a perfectly shaped six-sided jet stream spinning non-stop for at least 40 years since spacecraft first noticed it. Wind streams racing around the pole naturally lock into this geometric pattern. That hexagon stretches hundreds of miles deep into Saturn's atmosphere. Now let's hop onto Venus, where the climate spirals completely out of control. At its south pole, a spacecraft saw a massive double-eyed vortex, roughly the size of Europe, spinning endlessly in thick yellow clouds. Unlike Earth, where the atmosphere mostly moves together with the planet, Venus has something called superrotation. Its atmosphere races around the planet about 60 times faster than the surface below. Winds roar at speeds near 250 miles per hour. The surface temperature there is around 870 degrees Fahrenheit, hot enough to melt lead, zinc, and many spacecraft components. It's so hot because sunlight enters easily, but dense carbon dioxide traps outgoing heat so efficiently that cooling never happens. Even rain behaves cruelly there. Sulfuric acid forms high in the clouds and falls downward, but intense heat evaporates the droplets before they ever reach the ground, and rain just disappears mid-air. Well, our final stop of the day is Neptune. It receives only a tiny fraction of the sunlight Earth gets, but somehow drives jet streams exceeding 1,300 miles per hour, twice faster than the speed of sound. Heat must be rising from its interior to fuel such speeds. When Voyager 2 flew past in 1989, it spotted the Great Dark Spot, a storm system roughly the size of Earth itself. Neptune's storms appear and disappear within years, and behave like living systems that constantly evolve. Some of its storms drift toward the equator and then suddenly reverse direction. That never happens on Earth. So Neptune is another reminder that weather in space doesn't always follow familiar rules. Sometimes, physics builds systems so extreme that scientists can't explain them even after decades of observation.
Have you heard about a diamond star that could put all the riches on Earth to shame? Or how about twinkling stars with surfaces made of solid iron? So let's take a look at these weird stars and try to unravel their mysteries. There's a star in the Centaurus constellation that was nicknamed Lucy in the Sky with Diamonds. Yes, it was named after a Beatles song. because it basically is a Beatles song. You see, the star was discovered to have a massive diamond at its core. Now, you may be wondering how big this diamond really is. Well, it's estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. To put that into perspective, the Hope Diamond, which is one of the largest diamonds on Earth, is a measly 45.5 carats in comparison. Can you imagine the size of the ring you could make with this star diamond? And it's about the same mass as our sun. But don't get too excited about the prospect of owning this diamond just yet. Even if you were Jeff Bezos, you wouldn't be able to afford it. According to Ronald Winston, CEO of Harry Winston Inc., the diamond is so big that it would likely depress the value of the market. So you'd have to settle for a much smaller diamond engagement ring. One interesting thing about the Lucy in the Sky with Diamonds star is that it's incredibly dense. In fact, it has the mass of the sun crammed into an object only a third the diameter of Earth. That's like trying to fit an elephant into a shoebox. And yet, despite its massive size, it's actually quite cool, with a core temperature of only about 12,000 degrees Fahrenheit. By comparison, the core temperature of our sun is about 27 million degrees Fahrenheit. Since the discovery of Lucy in the Sky with Diamonds, several other crystallized stars have been found, some with diamond hearts the size of Earth. It just goes to show that the universe is full of surprises, and you never know what kind of treasures you might find out there in the vast expanse of space. And this isn't the only weird star we've discovered so far. There are many strange, unexplained things in outer space. For example, let's take Vega. Vega, also known as Alpha Lyrae, is a bright star located in the constellation Lyra. It's one of the brightest stars in the night sky and is easily visible to the naked eye from most parts of the world. Now, Vega may look like a beautiful, bright star to us Northern Hemisphere folks, but little do we know, it's hiding a secret. It's actually quite squashed. You see, Vega's high spin rate causes it to bulge at the equator, kind of like a cosmic belly. It rotates once every 12.5 hours, which is pretty fast for a star, and it throws material out around its waistline. It's almost like the star is hula hooping. This material is further from the center of the star, so it experiences less gravity, causing it to cool and darken, leading to a gravity darkening effect. So Vega is basically a cosmic fitness guru's worst nightmare. Although for us stargazers, it still looks round because we're looking at it from Earth's pole end. However, if we saw it from a different angle, we'd get a very different view. One that might make us wonder if Vega has been sneaking some cosmic donuts behind our backs. But while we might joke about its equatorial waistline, there's no denying that Vega is still one of the brightest and most fascinating stars in our galaxy. But if you want something actually bright, then how about a supernova? Supernovas are giant space booms that occur when stars reach the end of their life cycle. It's like the grand finale of a fireworks show, but on a cosmic scale. They release more energy in a few seconds than our sun will produce in its entire lifetime. And this is exactly what happened to the next star of our show. This celestial object with a weird name, IPFT 14HLS. But there's a catch. It isn't your average supernova. Even though this star made a blast in 2014 and started to fade away like usual, recently it made an unexpected comeback and brightened once more. Talk about a dramatic entrance. And if that wasn't enough, this thing continued to fade and brighten at least 5 times in total, which is a bit like a yo-yo. It's like the star just couldn't make up its mind about whether it wanted to stay bright or fade away into the abyss. Also, When scientists measured the supernova's spectrum, they found that it was evolving 10 times slower than other stars. Maybe it's a supernova that just wants to enjoy its golden years. All in all, this object is a real mystery. But this is not the only star suffering from the two-in-one syndrome. At first glance, MY Camelopardalis appears to be a fairly common star, but after a closer look, astronomers concluded it was actually two stars in one. These two stars are orbiting each other at over 600,000 miles per hour. It's a contact binary star system, which means that the stars are so close together that they share a common envelope. In other words, they're so close to each other that they're practically smooching. These celestial Romeo and Juliet are one of the most massive known binary stars out there. Each of them individually weighs in at a whopping 32 and 38 solar masses, respectively. Astronomers also think that they might be on the brink of a stellar merger, which means that one day they might just combine into one giant superstar. Wow, who knew space could be so romantic? Next, introducing another long name, HD 140283, also known as Methuselah's star. This little guy in the constellation Libra has been around for a while, and by a while, I mean a really long time. Actually, scientists used to think it was older than the universe itself. Just imagine if it turned out to be true. But eventually, they figured out that it's actually around 14.8 billion years old, a peer of our universe. That's still pretty impressive though. This star is so old, it remembers when the Milky Way was just a baby galaxy. But despite all that, this star still has some life left in it. It's just starting to expand into a red giant, which is kind of like when you hit your 30s. Talk about aging well. But if all these things are somewhat comprehensible, then how about a star that was literally named WTF star by scientists? No, I'm not kidding. At least it used to be. Now it's called Tabby's star. It also has a more scientific name, but that one is a bit of a mouthful. But what's really bizarre about this star is its irregular dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turned on and off a flashlight. And it's not just a little dip, we're talking up to a 22% drop in light. So it's not because it sometimes gets blocked by a planet or something. Scientists have come up with all sorts of explanations for this strange behavior, from comets to dust to even an extraterrestrial megastructure. That's right, but before your imagination runs too wild, it's important to note that the most likely explanation is just plain old dust. Perhaps the star is surrounded by some kind of dust cloud, and sometimes it prevents us from seeing it clearly. Although this explanation is still not 100% confirmed, there are still plenty of mysteries surrounding Tabby's star. One thing's for sure, it may be a bit of an oddball, but that's what makes it so fascinating. So, there you have it, folks. We're left in awe of the incredible diversity and strangeness of the cosmos. There's so much more to discover out there. So, let's keep exploring and keep being amazed by the wonders of the universe.
Check out that buff dude over there with the orange skin. He's been chilling on Mars for a hot minute, which is why he looks like he used the wrong shade of self-tan. You see, all those carotenoids in carrots, sweet potatoes, bell peppers, tomatoes, and pumpkins are protecting him from those UV rays. The more he eats, the more orange he gets. And as for his sturdiness, it's all about that Martian gravity. The gravity here makes us perceive our weight differently. And if you want to be a boss on Mars, you gotta eat heavily. Like, if a person weighs 150 pounds on Earth, it feels like no more than 55 pounds on Mars. So, overeating can help shorten that gravity to weight gap. Mercury is a whole different thing. It's hotter than Georgia asphalt during the day, but colder than Elsa's castle at night. You gotta be made of metal with a high melting point to be able to survive here. But for us regular humans, we'd be toast. Literally. Even though Mercury is the closest planet to the Sun, Venus is still the hottest one. Life on Venus, more like life on the Sun's evil twin. The temperature here typically hovers around 870 degrees Fahrenheit on average. Surviving at the boiling point of water, or in the extreme heat of Venus, is a challenge for most earthly species. Only a select few can endure boiling hot temperatures. Others rush to Starbucks to grab an iced latte with the first beams of the spring sun. So no human being can really evolve enough to survive on Venus. The only creatures that could thrive there are probably tardigrades and those weirdos who put hot sauce on everything. You wonder what tardigrades are? Well, those are minuscule and adorable caterpillar-like creatures that possess remarkable durability. They can endure boiling water, the depths of a sea trench, and the frigid, lightless void of space. Recently, tardigrades were included in a scientific study aboard a spacecraft that unfortunately crashed on the moon. Scientists speculate that the tardigrades may have survived the impact. Hey, would you like to turn into this creature and live on Venus? We're done with terrestrial planets. Let's move on to gas giants. Now look at this dude from Saturn. He's got flippers and not arms. He's got small holes with no external ear flaps instead of regular ears. Most of this gas giant is colder than your ex's heart, as the temperature is about minus 220 F. You can't walk on it, but you can turn into a snowball or an ice crystal if you're feeling frisky. Things are quite similar on Jupiter, so probably turning into a seal and chilling there is not that bad of an idea. At least you can live there rent-free. And don't even get me started on Neptune and Uranus. These guys are ice giants with no solid surface, so those sharp-clawed dudes you see in movies? Yeah, they don't exist. Plus, these two ain't exactly hospitable to life. I'll stick to my sweet potatoes on Mars. Thank you very much. During the recent years, scientists made two breakthrough discoveries about our universe. Thanks to new technologies, we've looked into the distant past. And we've learned something that can change our understanding of the universe forever. What are these discoveries and what do they mean to us? Let's find out. Recently, we unveiled the first color image from the James Webb Space Telescope. It's a mind-bending photo capturing thousands of ancient galaxies. This oldest documented light in the history of the universe dates back over 13 billion years. That's just 600 million years after the Big Bang. It's like getting a sneak peek into the universe's baby album. But that was just the beginning. Astronomers were expecting to see some tiny young galaxies, but what they found was a real surprise. Impossibly early, impossibly massive, and all that from just a tiny red dot. The lead author of the study, Ivo Laba, was working at the computer as usual, and suddenly he got two numbers. Age, 13 billion years. Weight, 100 billion stars. When he realized what that meant, he nearly spit out his coffee. But that red dot was just the beginning. The next day they found 5 more galaxies just like this. Turns out, these 6 massive galaxies are as old as the Milky Way itself. The entire research team was in disbelief. They were like, wait, what? These guys couldn't be that mature so early in time. Did we make a mistake? But nope. The James Webb Space Telescope, the new cool guy on the space block, just has some serious skills. It can see through dust clouds with its infrared vision and spot galaxies that were previously invisible. Move over Hubble. There's a new stargazer in town. But why is it shaking things up so much? Because this discovery affects our understanding of how galaxies formed. Let's try to explain. A long time ago, 13.8 billion years ago to be precise, our universe was born. It was chilling out for a while, and then it started to form the first galaxies. And these galaxies were full of gas and dust. Eventually, this gas started turning into stars. Some galaxies were more massive and had more stars, and some were lighter and had almost no stars at all. In any case, they all grew gradually. The stars in them were born slowly and smoothly. That's how our current models explain this. But these new observations from the James Webb Space Telescope show an unexpected surprise. Looks like, even in the early universe, our ancient friends had lots of stars. More than what we would ever expect. If that's the case, then these galaxies are like the overachievers of the universe. They skipped the small and gradual growth phase and went straight to being giant universe breakers. According to our current cosmological model, they shouldn't even exist. But they do, so it looks like after the Big Bang, the stars were forming much faster than we thought, which is pretty weird. This could mean that there's something missing in our understanding of the galaxy formation. As you can see, these universe breakers are really living up to their name, causing a potential total consensus among scientists. The universe was like, hey, I'm about to flip cosmology models upside down. But let's not jump to conclusions. There are many theories that could explain these mind-boggling discoveries without breaking the standard model. For example, maybe the light we're seeing isn't coming from stars at all, but from the swirling disks of doom around supermassive black holes. These colossal cosmic beasts can gobble up matter and spit out a dazzling light show. And James Webb Telescope's keen eye is picking up on these enigmatic accretion disks like never before. Or maybe these galaxies could be playing hide-and-seek with us. Maybe there's more to the story that we haven't seen yet. After all, the universe is vast and mysterious, and we've only just begun to scratch the surface. And whoa, we really need to slow down here. Before we even try to explain all this stuff, we need to confirm whether these ancient galaxies really are that old. Although even if they're actually just supermassive black holes, it still shows an astounding change. We'll have to wait about a year to find out. One thing's for sure, the James Webb Space Telescope has definitely taught us a valuable lesson. Expect the unexpected. And this is just the beginning of unexpected. Evolaba's team wasn't the only one who made such a huge breakthrough. There's also a team that claims that they've unlocked the secrets of the universe's past, and that's worth 2 Nobel Prizes. Move over James Webb Space Telescope, because this discovery came from an antenna that's smaller than a fridge and costs less than $5 million. Talk about space bargain hunting! The astronomers caught this signal that showed some surprises. It was coming from the earliest stars of our universe, back in the days when they were just beginning to twinkle. Say hi to our celestial ancestors again. Now, the signal was pretty weird. The temperatures were unusually low, and there was a pronounced wave that left astronomers scratching their heads. What could be causing all this? Well, there's a theory. Dark matter may have been at work, and if that's the case, then we can really be on the verge of a great discovery. Imagine you're looking at the night sky filled with stars, but there's something else there that you can't see. It's like an invisible cloak that covers the entire universe. Scientists call this mysterious stuff dark matter. Dark matter is like the ghost of our world. It doesn't emit, absorb, or reflect any light. We can't see it with telescopes or our eyes. That's why we call it dark matter. But if we can't detect it in any way, how do we know it exists? Because of its gravitational pull. One day we noticed that our understanding of how galaxies were created was incorrect. According to our calculations, they should have been some chaotic gas, but something held them together, turning them into spirals, like some kind of invisible glue. Then we thought, maybe this invisible glue really exists. If the moon was invisible, we would still suspect that it exists somewhere because its gravity affects the tides on Earth. This is also the case with dark matter. Its gravity influences the motion of galaxies and other cosmic objects. In fact, dark matter makes up a huge chunk of the universe, about 27% of it. Moreover, the normal matter we can see, like stars, planets, and galaxies, only make up about 5% of the universe. So even though we can't see dark matter, there's actually more of it in the universe than everything we can see. Scientists are still trying to figure out if dark matter exists and what it can be made of. Some theories suggest that it could be made up of exotic particles that are different from the particles that we're used to. Others think that it might be some kind of weird, undiscovered form of matter that doesn't interact with light at all. Anyway, it's an intriguing mystery, and if we ever confirm the existence of dark matter, our understanding of our world will change forever. So now you can understand why the excitement in the scientific community is palpable. If this discovery is confirmed, then we will get the first real proof of dark matter. This discovery may be even more important than the Big Bang itself because, as astronomers put it, we are made of star stuff, and so we are glimpsing at our origin. But of course, we still have to wait and explore all this in great detail. In science, one should never rush to conclusions. And while scientists study this stuff, we'll be here, on the edge of our seats waiting for the next space blockbuster to unfold. The universe never ceases to amaze us with its wonders. Who knew that such a small and humble antenna could unlock such cosmic secrets? It just goes to show that in the vastness of space, even the tiniest discoveries can have the biggest impact. Keep looking up, and who knows what other cosmic surprises are waiting to be uncovered.
Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Wait, hold on. What Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man named Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers at that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our Sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea. Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the Sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or even get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Small ones are just often piles of rubble, loosely held together by gravity. And the tiniest objects in the asteroid belt resemble dust, so small they are. And all these objects, giant and tiny, orbit the Sun. There are several types of asteroids, depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface, silicon ones, you can also call them stone asteroids, and metal ones. The first two types account for around 75% and 17% of asteroids that we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The the spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen. And since that time, 8 more probes have traveled through the asteroid belt. And now, I'm going to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems. And if it's just our galaxy alone, what can we say about the whole universe? Now, our Sun is also insanely massive. Here's the proof. 99.86% of all the mass of the solar system is the mass of the Sun, in particular hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Oh, by the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. Now, one phenomenon astronauts should worry about while exploring space is cold welding. If 2 pieces of the same kind of metal touch in space, they bond and get permanently stuck together, kind of like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses even though the Moon is 400 times smaller than the Sun. It's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the Moon won't be able to block the Sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massy icy objects. The most curious thing about this space formation, though, is that the scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 25,000 miles, which is actually almost the same as the circumference of Earth. Now, people got to know about beautiful Saturn's rings in the 1600s, but now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky material and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyways, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars?
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the Sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the Sun takes 153 hours, because it's pretty far away from the Sun. After several hours without sleep, we get tired, and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches. So it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the Sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the Sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home. Not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us. Tired of waiting for colonization? Does the Earth seem way too boring with all its problems and mosquitoes? Well, have no fear. It's time to take matters into your own hands and build your own planet. But before you start reaching for the cosmic glue and glitter, there are a few things you'll need to consider. Let's start our ultimate DIY project. First of all, we need to choose a location. Every planet has to orbit a star, right? In a cosmic buffet, every star has its own unique flavor. To keep things organized, astronomers use the so-called stellar classification system. The massive stars are the divas of the cosmos. They're huge, bright, and are always stealing the spotlight. But it's not all sunshine and rainbows. They have a short lifespan, burning out super fast, like a candle. They also have huge gravity, so be careful that your planet doesn't get sucked in. The dwarf stars, on the other hand, may be small, but they make up for it with their stamina. They can burn for trillions of years, which means that their planets have plenty of time to develop life. Super hot stars are blue or white ones, while the cold stars are usually red or orange. Yeah, seems like it should be the other way around, but we're not the ones making the rules. So what do we choose? Well, the planets around the blue and white stars could be scorched and fried, like a crispy chicken nugget. On the other hand, with cool red stars, our planet may turn into an ice ball. If that's your preference, then sure. But you can always pick a nice middle ground, a yellow star like our sun, for example. Not too cold, not too hot, but just right. Now that you've picked the star, let's start building the planet. The heart of the planet is its core. The core creates a magnetic field, an invisible force that protects a planet from harsh cosmic rays and charged particles. If it weren't for this field, the planet would be fried by the star's radiation, like a well-done burger. But the magnetic field isn't always a force for good. On some planets, like Jupiter, it's so strong that it creates super intense radiation belts and some crazy weather. If you were hoping to use a compass to find your way around on such a planet, forget it. The magnetic field would have the needle spinning like a breakdancer on caffeine. So, if you pick a small light core, the planet will have less protection from solar radiation, like tanning without sunscreen. On the other hand, larger cores can generate more heat, which can lead to more volcanic activity and earthquakes. The best option is a medium-sized core made mostly of iron and nickel, enough to keep the bad things away, but not too strong to turn a planet into a cosmic hot potato. Once the heart is in place, we can move on to the next step. Planets are like onions. They have layers. Most planets have three main layers: the core, the crust, and the mantle. The core is the filling, as we've already discussed. The mantle is like a hot and gooey layer of caramel between the crust and the core. And the crust is like a thin layer of icing on a planetary cake, covering its surface. But not all planets are built the same way. Because of that, we have tons of options. First up, we have the gas giants, the big boys of the universe. In our solar system, it's Jupiter and Saturn. They don't have a crust at all. They're basically huge balls of gas, like hydrogen and helium, hence the name. Next, we have the ice giants, like Uranus and Neptune. They're like younger, cooler siblings of gas giants. These planets don't really have a solid surface, but it's not pure gas either. They're made mostly of water, ammonia, and methane ice. There are also ocean worlds, and no, they aren't made of pure water. They do have some kind of solid surface, but it's located so deep, and the ocean on their surface is so huge that it kinda does look like a giant water drop. Finally, we have terrestrial planets, like the Earth. They're made mostly of rock and metal. These planets have a surface to stand on, and usually come with a cool mineral collection. And let's not forget about the dwarf planets, the small but mighty. Pluto is probably the most famous one, but there are others in our solar system: Eris, Ceres, Haumea, and so on. They're the scrappy underdogs of the planetary world, always trying to prove their worth, but never making it to full-fledged planets. Which type do you like the most? Gas giants are probably the coolest ones with their enormous sizes, crazy winds, and scary lightning. We also need to create an atmosphere. It's the outer layer of a planet that plays a huge role in its climate and weather. It's also the planet's ultimate protector. Did you know that 90 to 95% of meteors burn up in the Earth's atmosphere? Imagine what would happen if they didn't. Dense and hazy atmospheres, the ones you'll find on places like Venus, have thick layers of carbon dioxide and sulfuric acid. In other words, it's not a planet, but an oven. It's so hot that you could cook a pizza on its surface in no time and get cooked yourself. Next, we have thin and wispy atmospheres, like on Mars. The thin layer of carbon dioxide makes its surface pressure about 1% that of Earth's. On planets like these, you could fly like a superhero if you had a good enough jetpack. Then we have mixed atmospheres, like the one on Earth. The layers of nitrogen, oxygen, and other gases create the perfect conditions for life as we know it. It's also where we get to enjoy sunny days, rainbows, and of course, water. And last but not least, exotic atmospheres. You'll find them on planets like Neptune, where the layers of hydrogen, helium, and methane create a blue-colored world that looks like a giant marble. They're super weird and unusual, so just perfect for creative planet builders. Almost done. The final question is, would you like your planet to have life on it? In that case, there are some things you should consider. For example, it should be located in the habitable zone. This is the sweet spot around a star where conditions are just right for liquid water to exist on the surface. make sure your planet isn't too close or too far from its star. And don't forget about the temperatures. For example, you'll want a good amount of oxygen for a planet to be nice and warm, but not too much that everything spontaneously combusts. Of course, we need some water, but not too much, and a stable climate. You don't want your planet to be going through extreme swings in temperature or moisture. That's a recipe for extinction, not evolution. Oh, and the orbit should be stable, so that there are no major astronomical events that could throw things off. As you can see, this type of planet is very picky. No wonder it's so hard to find extraterrestrial life. Anyway, now that we've finished messing around in the Planet Creation Editor, how do we even build it? Well, how about terraforming? It's when we deliberately alter a planet's atmosphere, temperature, and other conditions to make it habitable for humans and other Earth-based life forms. For example, we could release greenhouse gases on Mars to warm up the planet and create a thicker atmosphere. But this method is more like polishing a monstrosity that was given to you by a character randomizer. What about building from scratch? That's something straight out of sci-fi. But maybe in the future, we could do that, using large-scale 3D printing or nanotechnology. We could create the basic structure and then add all the necessary conditions for life to exist. Of course, all this is still purely theoretical. But while creating a planet artificially is still a long way off, there are many creative ideas and concepts being explored by scientists and sci-fi writers. Who knows what the future might hold for the possibility of creating new worlds?